Today, I will talk about differentiation and techniques of differentiation. What is differentiation? Differentiation is an important topic in calculus. It is a method used to measure how a quantity changes with respect to another quantity. For example, differentiation can help us determine how fast a car is moving at a certain moment or how quickly the temperature changes over time. In mathematics, differentiation is used to find the instantaneous rate of change and also the slope of a graph at a particular point. The answer we get after differentiating a function is called the derivative. Techniques of differentiation. There are 7 main techniques in differentiation. First one is power rule. The power rule is the simplest and most commonly used technique. Technique number 2, which is product rule. The product rule is used when two functions are multiplied together. Number 3, quotient rule. The quotient rule is used when one function is divided by another. Next, chain rule. The chain rule is used by functions inside another function. Technique number 5, trigonometric differentiation. This technique is used for trigonometric functions such as sine, cosine, and tangent. Technique number 6, exponential and logarithmic differentiation. This method is used for exponential and logarithmic function. Number 7, implicit differentiation. Implicit differentiation is used when y is not separated clearly from x. So today, I will explain the step that used to differentiate this function for question number 1. We will use the product rule because the function consists of two functions multiplied together. So first, we will identify u in v, which is the product rule. First, we let u equals to 4x plus 10 power of 5 and v, which is 1n, bracket 4x plus 1. Next, we differentiate u. We use the chain rule because there is a function inside the bracket. So u will equals to 20 bracket 4x plus 10 power of 4, which is, we already simplify it. So now, we're moving forward to differentiate v, which is 1n bracket 4x plus 1. The derivative of 1n x is 1 over x, and again, we use the chain rule. So we will get 4 over 4x over 1. For the next step, we're moving forward, we substitute u, v into the product rule formula. We can get dy dx equals to 20 bracket 4x plus 10 power of 4, and then 1n bracket 4x plus 1 plus with 4x plus 10 power of 5, and then bracket 4 over 4x plus 1. For the next step, we can simplify by factoring out the common factor, which is 4 bracket 4x plus 10 power of 4. So we will get dy dx equals to 4 bracket 4x plus 10 power of 4, and then bracket 5n, 1n, then bracket 4x plus 1 plus with 4x plus 10 over 4x plus 1, and then we will put the bracket. So for the final derivative is dy dx equals to 4 bracket 4x plus 10 power of 4, and then bracket 5 1n, bracket 4x plus 1, bracket again, and then plus with 4x plus 10 over 4x plus 1, and then bracket. So this question shows how the product rule and chain rule can work together when differentiating more complicated functions. So next, I will pass to my friend Joel.
Thank you, Xavier, for the explanation. We move up to question 1b. In this question, we identify that the function asks a question because cosine is divided by exponential function. In this case, we will use the quotient rule. So, let u equals to cos 3x minus 5 and v equals to e power of 2x minus 5. We will differentiate each part using the chain rule. So, from u, it will become u prime, and it is equal to negative 3 sin 3x minus 1. For v, it will become v prime, and v prime equals to 2e power of 2x minus 5. After that, we substitute everything into the quotient rule formula. After simplifying and factoring out the e power of 2x minus 5, one exponential cancel with the denominator. Finally, the final answer that we get is dy dx equals to negative 3 sin 3x minus 1 minus 2 cos 3x minus 1 over e power of 2x minus 5. And that's the final derivative for y equals to cos 3x minus 1 over e power of 2x minus 5.
Alright, next up is question 2, where the question asks to find the dy over dx for 10x cubed negative 4x sine y squared equals to 1 over e power of y plus 5 natural log of 3x negative 1, using the implicit differentiation. First up, we have to find the differentiation of each functions. So the first function is 10x cubed, where we use the power rule to derive it, which will get us to tx squared. For negative 4x sine y squared, we will use the product rule, where the formula is u prime times v plus u times v prime. And the final derivative will be negative 4 sine y squared negative 8xy cos y squared dy over dx. Next, the derivative of 1 over e power of y prime uses the exponential differentiation, which will get us negative 1 over e power of y times dy over dx. The last function is 5 natural log of 3x negative 1. The derivative technique is the logarithmic differentiation, and this will get us 15 over 3x negative 1. Finally, we can substitute all of the functions with its derived counterparts, which gets us 30x squared negative 4 sine y squared negative 8xy cos y squared dy over dx equals to negative 1 over e power of y times dy dx plus 15 over 3x negative 1. Then we substitute it, which gets us the final answer of dy over dx equals to 15 over 3x negative 1 negative 30 x squared plus 4 sine y squared over 1 over e power of y negative 8 xy cos y squared.
So now I'm going to talk about question 3. So question 3 asks us to use the linear approximation to estimate the value of 2 over square root 80.44 plus the fourth root of 80.44 correct to 3 decimal places. So we started by writing down the fx equals to 2 over square root x plus the fourth root of x. And then we write down x equals to x naught plus delta x. So we know that the x equals to 80.44. So we put x naught equals to 81 because it's the closest to 80.44, and then plus, so the delta x, we put it as negative 0.44. And then we find the f prime x, so it will be equals to negative x power of negative 3 over 2 plus 1 over 4 x power of negative 3 over 4. And then we find the f x naught equals to 2 over 80 square root of 81 plus the fourth root of 81, and it will be equals to 29 over 9. Then we find the f prime x naught. The answer is 23 over 2916. And then we sub all the finding just now inside the given formula, which is f x naught plus delta x approximately equals to f x naught plus f prime x naught times delta x. And then we just put it inside the equation, and then we will get that it is approximately equals to 3.218. That is the final answer. Thank you.